All right, so we're talking about perimeter and area. And my question is, right up at the top here, how do you find the perimeter of a figure? You look at the outside. So for example, if you were to walk around the perimeter of the basketball court, where are you walking? You're on the very edge, right? A lot of times a perimeter is used, you can think of it as like the fence. The fence of your yard defines the perimeter of your yard. Okay? So how would you find the perimeter of it? Add up all the sides. That's how we find the perimeter. How do you find the area of a square or a rectangle? Now the area is a little bit different. For example, if I talk about this classroom, the perimeter would be the length of all the walls added together. What would the area be? It would be like the amount of carpet that's needed to cover the floor, right? So it's the inside space. Now we're going to stick basically with rectangles and squares. How do you find the area of a rectangle or a square? Base times height. Some people think of it as length times width. That's really the same thing, right? Just depends on whether you call it a length or a base. But it's one side multiplied by another side that's perpendicular to it. That's how you find the area of what's inside. Okay? So we have a little drawing here. This looks like a farm, I guess. They are growing various vegetables, it looks like. And we have the north side, the south side, the east side, and the west side. So the first question says, write an expression that represents the south side of the field. Well, if I use my little north, south, east, west, this would be the south side of the field, correct? So how could I find, or what expression would I use if I wanted to find out the length of the entire south side? How would I do that? I would have to add these three things, right? So in essence, I could write it like we've been doing with our adding polynomials. There's the first one, right? That's the first chunk of field. Added to the second chunk of field, that's the corn part. And then added to the third part, the potatoes part. Does it say to solve it or simplify it? No, it just says to write the expression. But what do you notice number 2 says? It says to simplify that polynomial expression. So, if I want to simplify that, I would put the ones right here, correct? So 1 times 5x would be 5x. 1 times 2 would be 2. 1 times x squared. 1 times negative 9. 1 times x squared. 1 times negative 7x. And 1 times 12. So let's see, if I write my answer in standard form, what am I going to combine first? I'm going to have 2x squared. Then how many x's am I going to have? 5x and negative 7x, what does that give me? Negative 2x. And then finally, positive 2, negative 9, and positive 12. What does that give me? Well, 2 minus 9 is negative 7, plus 12 is plus 5. So that would be my answer to part 2, or question 2. Okay? All right, number 3, write a polynomial expression that represents the perimeter of the pumpkin field. Well, my pumpkin field is right here. And how did we decide that you find the perimeter? You add up all the sides, but only 2 sides are labeled. Do you see that? And there's 4 sides. So how can I add up 4 sides if I only know 2 of them?
It's a square. They're all the same.
It's not a square. It's a rectangle. So if this side is 5x plus 2, this side is also 5x plus 2. And if this side is 5x minus 2, the one across from there is also 5x minus 2. So the perimeter would be 5x minus 2 plus 5x plus 2 plus 5x minus 2 plus 5x plus 2. Can you think of another way I could express that perimeter?
5x minus 2 squared plus 5x plus 2 squared.
So close. Not squared, but something else. I'm not multiplying 5x plus 2 times 5x plus 2, so I can't square it. I'm taking it and I'm using it twice. So I would do 2 times 5x minus 2 plus 2 times 5x plus 2. Because 5x plus 2 happens 2 times, I multiply it by 2. Because 5x minus 2 happens 2 times, I multiply it by 2. That's another way I could express the perimeter. Okay? What does number 4 say? Simplify that one. I'm going to simplify this one because it's going to be less that I have to distribute, right? Yeah. So let's see. 2 times 5x would be 10x. 2 times negative 2 would be, and then 2 times 5x is, and 2 times 2 is 4. So I have 10x plus 10x, which is 20x. And what about negative 4 plus 4? That just cancels out, so I just have 20x. Would be my expression that represents the perimeter of the pumpkin field. Okay? Kind of sort of get the idea of perimeter. All right, because the next one doesn't ask for perimeter. What does it ask for? Area. And which field are we looking at? Potatoes. So here's my potatoes. How do we find area? Base times height or length times width, whatever you want to call it. But regardless, if this is my potato field, I need to take this and multiply it by this guy, right? Now, is it easier to have the one with 3 terms first or the one with 2 terms first? It really doesn't matter, but a lot of times people think the smaller number of terms first is easier. So I'm going to put the x plus 6 first. And then the second term, which is the x squared minus 7x plus 12. That's my polynomial expression. When it says simplify, what do I need to do? Simplify. How do I do that? So I've got a box thing going on, don't I? Now some of you I've noticed have found a way to use distributing instead of using a box. That's totally fine. Okay, x times x squared is x cubed. X times negative 7x is negative 7x squared. And x times 12 is 12x. 6 times x squared. 6 times negative 7x. And 6 times 12, 72. So I think I have, let's see, x to the third, what? There's one of my minus 1x squared, which actually, let me write that over. I would just write x to the third minus x squared, correct? What's negative 42x and positive 12x? Negative 30x and then plus 72. Capiche? Pretty easy?
Yeah.
All right, let's look at the back side. Find the perimeter and the area of the figure. Okay, well, perimeter shouldn't be too bad because it's just adding up all the sides, right? Do I know all the sides?
No.
Okay, well, let's fill some in. What's the length of this side? How do I know? Because it's directly across from this guy. What's the length of this side? 6. Now, here's my question. This is the tricky one. How long is that? How do I know? Well, I know that this whole thing is 8 centimeters, right? This is 5. How much is this? This is 2, right? So what does that have to be? 1. So if I add up all the sides, I have 8 plus 3 plus 1 plus 6 plus 2 plus 6 plus 5 plus 3. Why didn't I put the 2 in there? I put this 2, but I didn't put that one. Why didn't I put that one in there? Because that was going right in the middle of the field. It wasn't the actual perimeter, right? So I just got to add all these things up. 8, 9, 10, 11, 12, plus 6 is 18, 19, 20, 26, 31, 34. 34 what? That's my perimeter right there. Okay? So? It also says find the area. Now, I kind of gave a little hint away. By cutting it in half like this, I actually can find the area of this rectangle and then add it to the area of that rectangle. Because putting them together gives me the total area, right? How do I find the area of this top rectangle? Length times width. Or base times height. Either way, it's going to be 8 times what? Okay? So that top rectangle has an area of 24 centimeters, and we always use squared when we're talking about area because it's two-dimensional, whereas perimeter is one-dimensional. How do I find the area of this one? 2 times 6, or 6 times 2 is 12 centimeters squared. So if I add those two rectangles together, what have I got? 36 centimeters squared. When would that be helpful? When would it be helpful to find area? If you want to know what's inside something. For example, if you're ordering carpet for your family room, you want to know the area so you don't pay too much and order too much carpet. Or, worse, not enough. Right? You're painting your wall. You want to know approximately how many gallons of paint you got to buy. So you need to have an idea of the area that you are painting so that you purchase the correct amount of paint and not too much or too little. Okay? All right, find the area of the shaded region. I'm like 99% sure that there's going to be a question like this on the test. Now, let's think about this for a minute. If I were to find the area, if I were to multiply this length right here times this length right here, that's 27 times 10.8, which is what? 27 times 10.8 is, I get 291.6 inches squared. Is that what you got? Now, the problem with that is I didn't find the shaded region. I found the whole thing. So that 291 is representing that entire thing. How do I get rid of that part? Let's find the area of this part, and then we can subtract it from that. So how do I find the area of that part? 9 and 19.8 is my 291. Oops, hang on. 9 times 19.8. What'd you get? I got 178.2 inches squared. Now, if I know that the area of this whole thing is 291, then clearly the area of the shaded region, which is that outer band, should be less than 291, right? Okay. A lot of times you'll see this problem like, oh, there's a swimming pool, and you want to know what the area is of the walkway around the swimming pool, or something like that. So what am I going to do? This is the whole rectangle. This is the smaller rectangle. I am going to subtract. So 291.6 minus 178.2, 113.4, and how should I label it? Inches squared. Whenever you can, label it. Now be careful. Area is always labeled with the squared. Perimeter never has the squared. It all depends on whether it's a one-dimensional or a two-dimensional thing. Okay? Questions about this? All right, here comes your homework. Happy studying.